Nodevember 2020, second day. Candy. Today we will make our interpretation of a candy. Or I will make mine. And there is this famous tutorial about making a donut. And a donut is not a real candy, but I thought I will make this, but just with white chocolate. That will be fun. So we'll probably start from plain. We'll need a few subdivisions. Just put in a whole lot. And yeah, now we need to define our shape. We want a torus. So we will use vector displacement to get there. I'm just scrolling through here. Let's set up first. So I'm always just pulling out the nodes first that I will probably use, and then just duplicating them while working. So what else? Oh yeah, we do need the UV and the geometry node as well. Okay, let's start. So let's go into rendered view. There we go. Cycles, obviously. Because Eevee doesn't have the vector displacement yet. Maybe it will have at some time, but I don't know. Okay, so what we want is, first of all, put all the vertices into the center. So we can get their position here, and we can subtract it, and yeah, basically put that into the displacement. And this didn't do what I thought it would do. Or did it? Didn't. What is it? Oh yeah, the displacement is obviously not working because I need to enable it. Displacement only. Okay, now it's working. So then the next thing would be to use a UV. For example, I can just plug it in there, and we can see it's going from 0 to 1. That space, and we can now bend this into any shape we want, really. So I will separate it and combine it here again. So I have all my freedom in here, and we can make a torus. So what we need is sine and cosine. I'll just zoom in a little bit. Sine and cosine. So let's create the nodes like this. We'll need the cosine and the sine of x and of y. Then also we'll just need a vector scale. Wait, I did have the vector node. Let's put in multiply, right? Just go with those numbers. No, wait, let's put in the correct numbers. Pi and 2 pi. And just type that in there, it will calculate it and put it in. Okay, now we need to make a torus from this. So let's start by just looking at that stuff. Okay, now we have a cylinder, which is interesting. So x and y already defines the circle, and the z component is just cycling up and down, so we get the cylinder. And for a torus, basically you can look it up, so it's on Wikipedia, and the x-coordinate would be the cosine of r. So wait a second, let's make it, well, I'm always searching for this node. So we want to define first a sphere and then rotate it, basically, so we can do it that way as well. You don't need the Wikipedia article. Where is it? Rotate, right? Rotate along the z-axis. Okay, angle, that's probably our y-coordinate. Now we probably don't need these two nodes. I'll just shift them out. Define a circle here. We want the circle on the x and z coordinates, probably, we'll see in a moment. And we can scale the circle and then rotate it. So let's see if that worked. Okay, did some strange stuff, but now, well, that didn't work because we need to offset it. So we need to, oh, why is there an add node in there? Shouldn't be in there. This should be in here probably. Well, that's the z-axis, x-axis, right. So there we go. We have a torus. Yeah, we can make it any size we want. And this is a, oh, yeah, I did the scaling afterwards, so it will scale completely, and this will make it thinner or wider. This is, by the way, the donut that we are creating. Forgot to pull it up. Okay, so it seems like that's too wide. Let's put it in a little bit. What you bet? This is a good donut shape? Don't know. Yeah, probably. Okay. So let's oh yeah, of course. So we need to adjust this minor radius depending on the angle because we want this topping, right? So this won't work just like this. We need to have really a value where we can just tweak the minor radius. So let's pull this out of there and do the offset, add here, and what was the value? 1.78. Okay, this doesn't work for some reason. It's probably because it's on the wrong axis. So yes, okay. Okay, this does strange stuff. Let's just adjust it again. Okay, now it works. So this radius is now the donut radius. So we can adjust it depending on the position of the donut. So let's look at some values here. That value seems to dictate where we are on the donut. So there's a seam up here. We probably don't want it up here. So let's invert the z coordinate that we have here. Oh, we can delete this. Subtract, invert. That's one way of inverting it. Okay, now it's on the bottom, right. So we can now use that to determine our position in that coordinate, and we can use a noise texture for the other stuff, so for the sides, right? And we will need to see if we do this drops. Don't know yet. Okay. So combine. Actually, we didn't need. No, we have it there, so you can delete that. The noise texture should actually build on top of the final result of this stuff. So we need to duplicate all of this. Well, not all of it, just this part. And this and this. Right, we need to duplicate that because we want one for the coordinate space and one for the actual coordinates of the mesh. So let's reorganize this a little bit. You can put it out there. And this is the coordinate system of the mesh. Like that. You can see what I mean. So we can use that for determining where the topping goes. And we can use the other value that I just showed. Where was it? It was that value there. That value for determining this line here. So let's see if this is useful. Actually, we can just use the z coordinate. I just remembered. Well, we didn't need to flip it then, but yeah. Let's just undo the flipping here. That's just making it much more of a mess. Okay, so no flipping. Where is it? Oops, subtract. So we are subtracting off the top. Oh no, we probably want to add it, right? Or we just adjust it anyway, like this. Okay, multiply add. Look at this. So now we have white on the bottom. I did want white on the top though. That means I can just go negative value there and fade it like this. Okay, so now that's way too aggressive here. I mean, it looks kind of like the drops, so I kind of don't mind, but it's definitely too aggressive. Okay, so let's adjust some values here. Oh yeah, that looks good. That looks really good. And we can put it on with an animation. That's also pretty cool. Okay, let's just create a marker here to know that's the value that I would want to animate. So like that. Let's go on. We can create just some masks. So okay, I won't do it this way. I will do it the map range and go probably from 0.005 something. Yeah, like that. So we have a smooth edge, but it's still kind of sharp. That will make the geometry much nicer. So this can now go in here and just look at this. Look at this. We could also do another map range, but I kind of like to use this multiply add instead of a range for whatever reason. No particular reason though. Except it's like less values in here, right? Oh, no. Didn't want to change that. That's too much. Let's do a little bit less. A little bit more than that. Okay, like this probably. Let's see. Okay, so now we do have this weird edges because our mesh is not high res enough. But I don't care for now. I don't care because I think just upping the mesh resolution will fix that issue. Okay, so next thing, texturing. Just go and create basic materials for white chocolate and this topping, which we can just with the eyedropper get there. Let's do that. Make white chocolate somewhat the same color, but a little bit lighter and less saturated. This is probably a good color, but I just remembered it's probably better to have subsurf on there, so let's do that. It's a little bit too much subsurf though, so this is probably good because chocolate really is kind of this wax-like material. Do you call it wax? Don't know. Anyway, okay, now use the mask created here. There we go. That's it. Okay. I will ignore that. This is half pink and half white chocolate. Okay. Let's adjust a little bit of the colors because this is looking too yellowish. Should probably be. Yeah, this is much better. This is much better. It's still looking strange because of this subsurf radius. Probably should make the subsurf free white like that. Okay, that's looking fine now. yeah, it's actually getting the shape. I will subdivide it a little bit more though. Oh yeah, now it looks good. Okay. Now, the difficult part, right? The difficult part is these things down here. Particles, whatever. So I do have a plan to do that. Not sure if it will work though. So my plan is to use nones, the value none. So you know you can add a divide node and divide 0 by 0. What you get is basically none. So I hope at least that this will give me a none value. We will see that in a moment. My hope is that whenever I plug this into this, then everything disappears. But this does not look promising at all. This seems to be 0. Did they fix that? That would be bad. Let's take the logarithm of a negative value. To base 0? Wait, no, to base 1 or something. And again, do they just use 0 now? Can't understand that. Okay, so this idea might not work if there is no none values. Because I thought of chopping the original mesh up into a lot of sections by basically setting a few vertices to none, and that way they are basically not rendered at all. To just fail to render them. So I could have multiple islands. There's probably a way. So maybe positive infinity will work, something like that. What happens if I divide 1 by 0? It's still the same. Okay, so logarithm of 0 maybe. Did they fix everything here? Okay, let's take a ridiculous base and a ridiculous exponent. Let's check that out. Okay, that is doing something, but it's not... I guess the displacement just didn't work now. Well, that's too bad. Then there's no way to chop the mesh up. Anyway, we'll still do this topping, but it will be a lot harder, as we cannot use real geometry there. So let's do a map, a texture for that. I'll probably use Voronoi again, because I just like it that much. And now I kind of want to have the local, the surface coordinates, so I can go to the UV directly. Yeah, probably can just use it. Let's see. No, now it has. Okay. So now this is a problem that it has this seam up there. But we can fix that problem also in a different way, but don't think it's worth it to do that. Okay, so there it can be like that, but here we want to invert the z coordinate. Let's do that. Subtract 0, 1. Okay. Oh no. So now it's inverted. Okay, let's do that. Oh no. That didn't that fix it? It didn't fix it. We need to invert it. Fix it this way? Yes. Okay. Now it works again. So now we have the UV on the top continuous, except for this seam here. And we need to do something about that. So let's think about that in a moment. Well, actually, I think we did this the second time for nothing, because I just thought, what about a 2D texture from the top? Because we will only use the top section anyway. So we do need the normals for this, because we want only, oh no, we don't need the normals. We can just get this. And also we do have the normals, so this is the normal here. Well, the kind of the normal, not really the normal. It's on the original circle, that's the normal. Okay. So what we can do is use the final coordinates here, these, and map them in different ways. Okay, let's do this. We do need some vector stuff, so a dot product would be nice here. Let's get that. Actually, we not really need the dot product here. We could just use the cosine, but who cares? Who cares anyway? So this is the top now. We can use that map. It's just the z coordinate extracted. Could have used a separate instead. Let's do that. Just that. Okay. X and Y, they are not in here. So let's not use that output. Let's use this output. Actually, what happens if I put that in there? Okay, so this works. This is the regions that I wanted, like this. And the z coordinate here will dictate or control where there's actually the cell, or where there is a cell. Okay, so now I'm debating, because I do want only the cells that look upward, but kind of hard to tell from that thing, so I don't want half cells, that's the thing. Let's try a little bit. Put in the scales, okay, and we probably do need the same coordinates as well, but we can use different stuff here. For example, F2, not sure, we'll see if that's useful. Okay, but let's first of all do the simple way. The simplest way is always the best way. Always. Okay. Well, not really always, but most of the time anyway. Oh, I just noticed this is a scaled version, right? So we do need this version right there to get the normals. So this one, this should be 0.5 or something. So it's only there that we have these things. Yeah, and we will see how we mask off some of the cells. Actually, don't think we need that. Kind of screwed there. Okay, let's first of all get local coordinates of the Voronoi cells. That's pretty easy, so I do need that thing. And just subtract that. So now we have local Voronoi cell coordinates. We just reduce in randomness a little bit, so they are a little bit more equally sized, like that. Probably increase the resolution a little bit, like that. And now we can just put in those coordinates arbitrary particles. Okay, we don't only want these two coordinates. I just saw that there was a z coordinate down there. Don't want that to play a role here. So the axis, again, that's the correct axis. Just use the color input, because the color input will basically give us a random rotation. And I can multiply that by some number, and that will give us all sorts of rotations. Okay, from here we can go and make such a thing. So, well, there's multiple ways, but the simplest by far is probably to use a separate node and a compare. Let's pull that up. Where is it? Oh yeah, it's part of this, so let's just put it here. Compare, there's this epsilon value, which is really, really useful. So go like this and turn up the epsilon value. Okay, there we go. Now we have all the little particles. Yay! Make it a little bit more of them, like that. And we can color them as well, because we do have these colors here. So let's do that. And this is becoming a mess here. Just scroll it out a little bit, move it to the right, and get us a mix RGB. So this will go in there, and we can get our color and basically mix it with a neutral color, like black or something. Oh no. So there we just get our, how are they called? Particles. We just call them particles. Keep calling them particles. Oh, didn't copy it. So like that, we can put that in there, and now can not enjoy it. Wait, what happened? Why did that not? Oh, is it? Why is this grayed out? Okay, I'm confused. Did I make a cycle anywhere or something like that? Don't think I did. What's wrong? Just look at that. Okay, now let's just look at this. And the mix is messed up. Why is the mix messed up? What is this thing doing? It's putting it to, yeah, this shader. Okay, let's just ignore that for now. I also don't get why this is not. Yeah, see that? It disappears. So why why didn't it disappear here? Oh, oh, oh. Okay. Never had that issue yet. Oh no. Okay. Anyway, there we go. There we go. Now we have our particles on top. So obviously we don't want these particles down here. So that was what I was talking about a minute ago or something, or like that. So let's get a minimum, and now we need to select these. And that's kind of difficult because it's a 2D texture. We can put this to 3D, and this will give us a little bit more freedom there. So we can use this subtract thing, but we actually don't need to use that. Wait a second. Oh, now I have a plan. Okay, I have a plan. So let's use less than, oh, actually greater than would be good, I think. And put it into, separate the position here, get the z coordinate, put in a value. Let's see. Yes, it works. It's exactly what I wanted. Okay. And now minimum like that. There we go. We have our mask. And it's just doing it on the top. But we messed up with 3D things. So as you can see, 3D introduces all of these little bits, and I don't like them. I don't like them, to be honest. So let's just get rid of this again. Minimum, that should have a 1. This looks much, much better. So I'm debating now what to do. So we could either just roll with it, just use the other one, or we could do something smart, which I don't know what would be smart here. So let's just try the simplest solution ever, like that. Just cut it off. It actually doesn't look that bad, but well, no, that won't cut it. So okay, I have a plan. Okay, I have a plan. We can use this position here. Actually, not that one. Need to multiply it first. No, actually it has no z coordinates, so I can use that one. And oh no, well, don't care about that. Length, and get the length there. So now we do have a mapping here from inside to outside. So what we can do is use a map range, and then probably that at some point, and find a range which we like, where the outside is a 1 basically, and then use a ping pong. Yeah, that's actually a function in here. Let's use that, and 0.5 here, and yeah, this is the values. So let's get our topping. So we will need to get rid of the bottom, but for now that's fine. So just like that. No, that's actually too much. Like that. We can also get rid of a little bit here. Yeah, I think that's fine. That's fine. Okay. I'm not completely sold on this though, because what I want is a little bit more variation here. So let's try to do that. That should be easy. Let's multiply it like that. Get the color and just see what this does. Like that. Okay, it does something, but not exactly what I wanted. So that tweaks us a little bit. Yeah, we have too much down here. So let's decrease that a little bit more. And maybe increase this like this. Yeah, this might be good. Oh, didn't plug it in yet. Plug it in. Okay. Now we only have these things on top, and it's actually looking quite good. And we have the ones on the bottom. Okay, that's a little thing to fix. So we need a minimum again, like that, and like that. And now there's no things on the bottom. Okay, that's working. Now coordinates. We need to bump that a little bit. And we will use a combination of bump mapping and actual displacement here, because that's always nice. I did it also on the cookie, where I used a combination of those both. Those two, right. Height, put this into the normal of not this thing here. Don't do it into this. Like that. Okay. So, oh, it already looks a little bit more interesting. We have a problem that this is binary. It's on or off. So let's fix that. Should be an easy fix. So let's take the absolute value of x and multiply it and clamp that. No, clamp it. And let's see what we can do here. This is the wrong way around. Need to go negative. Right. Okay. And this should be basically at 1. Start at 1 and go negative. that. No, even more. Okay. Like that. Okay, nice. And that's exactly what I wanted. So the color can be binary, that's no problem. But the bump mapping, that shouldn't be binary. And absolute is actually not really what I want here. So what I actually want is some sort of cosine, but that's a little bit more difficult. We could do instead a parabola. So go with that. I need to increase this even more. Like that, and yeah, that's actually looking quite good. Now we need to match the sizes, but we can do that in a moment. The strength is way too high. Yeah, this is kind of strange. So it's really binary still. It's like on one side it's dark and on one side it's light. Maybe I should just don't overdo it here. And oh, I also have a problem with that. Let's fix that. We can combine these two masks before using it, so we can use it in one go, and we can also use it in there in one go, like that. Okay, and yeah, no, that's almost it. So where did we leave off? Here we need to put in an add. Okay, and then yeah, that's not what I wanted. Multiply add and do multiplication there. Yeah, so it's much too strong right now, and we can decrease it. It's actually already quite low, but yeah, that's probably as good as we can get with that. Just need to use a little bit of adaptive subsurf, and that's it. I think cannot go much better than that for now. At least not with this technique. Let's subdivide it once more. Save it. Yeah. It's fine though. It's fine. Just have a little bit of low amount. And the colors. The colors are completely crazy. Need to adjust that a little bit. So we can, for example, do that by multiplying that with a color that has no blue, for example. No blue. And then we can go and do the color correction, this hue saturation value, and shift the hue until we get to that color range there. So this is kind of close already. Oh, I'm on the limit. The saturation is a little bit high. Let's go down on that. It's also too spiky. Yeah, that's better. Maybe actually invert this. Did that help? I think this helped to make it the different way around, and then it's kind of detached a little bit. So don't look at it too close. That's the general rule anyway. And wait a second, just noticed this here is way not colorful enough. Okay. So the only thing that's left here is final tweaks, and then this is basically done. So I will end the video here and show you the final result.